Hello physics students. In this video I wanted to address some misconceptions about circuits, and this will help you complete the next assignment. The first thing is when we turn on a circuit like this, we know it's a combination of both series and parallel elements. These two bulbs are in series, these two bulbs are in parallel, and it's important to note that all the bulbs have the same amount of resistance. All right, so when I turn something on like this, we're going to see some bulbs are brighter and some bulbs are dimmer. The question always is why are some of these bulbs brighter and dimmer? And one of the common misconceptions has to do with proximity. So a lot of time people will think that the brightest bulb, this bulb right here, is brighter because it's closer to the battery or the voltage source. And that is incorrect. I want to explain why. Another misconception might be around how the electrons are actually moving through the wires. So let's talk about the brightness of the bulb. Why is this bulb brightest? It's not because it's closer to the voltage source or closer to the battery, but it's because each of these paths branch and then rejoin before it returns and completes the full circuit. So all of the current that's coming from the battery, this 0.54 amps, also is going through that one bulb. It has the highest amount of current, therefore it is the brightest bulb, and it has the highest amount of current because all of the branches are feeding through that to come back and complete the circuit. The more branches in a parallel circuit, the more current total is drawn from the battery. So since we have two branches, we're going to draw that more current, and it's all going to go through that single bulb. So that's misconception number one. It's not brighter because it's closer, but it's brighter because it has more current because of this parallel setup. The second one has to do with how the electrons are inside a wire. And a lot of times people use analogies when they talk about the electricity. And one of the analogies that people use is electrons in a wire are a lot like water flowing through a pipe or a garden hose. There are some elements of truth to that, but I want you to dig a little bit deeper because that could lead to some misunderstandings. Like, for example, when I turn this on, it's going to take time for all of the bulbs to light up. They won't all do so at the same time, but we know right away when I do that, it's not true. They turn on instantly. So it's not like water's flowing through this, or these are like pipes or tubes or garden hoses where the water has to leave the battery and take time to get to all these. Also, it doesn't mean that these bulbs would be brightest because they're getting the energy first and there's more pressure like there is in a hose. So those are misconceptions that can happen because of people thinking of it like a water hose. A better way to think about it is to actually think about that the electrons that will be moving to create current already exist in the wire. And it's more like a marble, a set of marbles that are already in the tube. And by adding one more marble, it bumps everybody else at the same time. So instantly, all at the same time, that electricity starts to flow and the current happens, not because the water analogy where the electrons have to leave the voltage source and make their way to all the elements. Rather, it's more like the marble where the one that is just coming out of the battery or that electric field that is instantly causing those electrons to move is happening across the whole circuit all at once. So let me show you. I'll turn this on. You can see the electrons in the wire. I'm going to turn this on and instantly everything moves, and it's happening all at the same time because of that potential difference generating an electric field inside that circuit. Hopefully this helps make some more sense of these things. Please test it out for yourself using the amp meter to judge these different currents. Separating out different bulbs will give you different results. Like, for example, by not having a parallel branch, it decreases the overall current. Therefore, I know that now these bulbs must have equal brightness because they're all sharing the same amount of current because it's a series circuit. When I reattach this, now I am generating a parallel circuit, again, a parallel going to series through that one bulb, and so all of that current is going through the final bulb, making it the brightest out of all of them. Please reach out if you have questions about this. Hopefully this clears up a couple of things. Thanks, and have a great day.